Hello, everybody. Welcome to the next installment in our monthly series on artificial intelligence, brought to you by the fine folks at Embedded Computing Design. This month, we are looking at machine learning for industrial applications. This webinar is sponsored by Pantherun. My name is Rich Ness, and I will be your moderator for this event as long as this storm holds up, because we're getting a wicked electrical storm going through right now. Hopefully, I don't get knocked off. But anyway, I'm also the Executive Vice President, Open Systems Media. I lead the content team for Embedded Computing Design. If you're not familiar with ECD, you'll find it's a great resource for anything related to the design of hardware and software for embedded systems. You can find it at www.embeddedcomputing.com. It's filled with design articles, white papers, blogs, videos, podcasts, and lots more. Back to the topic at hand, you likely know that machine learning is a subset of AI, at least in my definition. It's the part of AI where the machines take in data from a variety of sources, including the machines themselves, and make predictions or decisions on their own without any human intervention. That allows the performance of the industrial machinery, in this case, to continually improve their performance over time. It is very cool stuff. Our speaker for today is Srinivas Shekar, the CEO of Pantherun. Shri's been in this space for quite some time, involved in various aspects of cybersecurity, embedded product design, and high-throughput communications. He's clearly an expert in this space. Before I ask Shri to begin, let me go over some of the housekeeping stuff that you need to know about. His entire presentation will take somewhere around 25-ish minutes, and when he's done, we'll answer all of your questions. You'll find on the right-hand side of the console window an area where you can enter those questions in real time. If for some reason we don't get a chance to answer your question, somebody from Pantherun will get back to you after we sign off with an answer. If you have a question that pertains to the webinar operation itself, like if the slides aren't advancing right or there's trouble with the audio, one of our tech folks will respond if you put that question into the question box. There's also a tab there that says handouts. If you click on that tab, you'll be able to download a copy of the slides that Shri is presenting. Also in that tab, you'll find a link to register for the upcoming webcast in this AI series, as well as those that have already occurred in an on-demand format. This webinar will also be available in an on-demand format shortly after we're done. So if you missed something, you want to go back and review, forward to a friend or a colleague, it'll be there for you. Finally, for a full screen view of this presentation, you just click on the expand arrows located in the upper right-hand corner of the viewing area. And then to exit the full screen mode, press the escape button. That's all I got. Let's get to the meat of the matter here. Shri, take it away.
Thank you, Rich. Yeah. Hello, everybody. My name is Srinivas Shekar. You can call me Shri when you write to me or if you message me. It's wonderful to be here and to be addressing all of you. I am, that was a very generous introduction by Rich, and I thank him for that. But I am no expert. I'm also learning, like all of you, to figure out what works, what does not work, what helps build out industrial systems. To give you a little bit of background to myself, I've been a product designer, particularly in the industrial area for close to 30 years. Started off building ASICs for micromotor controls in the US, then built a whole range of programmable logic controllers, HMIs, man-machine interfaces, whole range of field bus implementations, also industrial Ethernet product range. So that's been my career, building products tailored towards industrial and military and railway applications. So coming to smarter machines, building safer networks, particularly in the industrial space. I'm also learning machine language, trying to figure out which of those approaches work in the industrial application space, whether it is to improve how devices can react to industrial situations, improve how they can provide control, improve how they can do monitoring, or improve the security features of industrial devices. These are all the areas that I taken a lot of interest in, and I work to build products on. So here we go with the presentation. So when you look at uh, the way technologies are converging today, you have AI, coming into industrial applications. Uh, we typically look at machine learning as a step that's more suitable for industrial applications. AI requires huge volumes of data. Machine learning takes lesser amounts, so it's able to provide much greater real-time performance. So machine learning is here to stay. It's going to make an impact on industrial applications. So that's something to pay attention to. Yeah. Edge computing is becoming more and more and more important as we go along. Yeah. Because edge devices, whether it's cameras, it's sensors, it's your industrial controls, it's drive controls, it's the layer 1, layer 2, and layer 3 networking devices. All of these devices, yeah, are going to have to make decisions. All of them will have machine learning and AI algorithms running on them, so that the data comes in real time, decisions happen in real time. Yeah. So edge computing is going to become more and more important. Yeah. We hear estimates that by the end of 2025, edge computing will dominate 75% of the market. That is, decision making on the edge will happen 75% of the time. So this is something to pay attention to. And of course, when you look at edge computing, when you look at decision making, you need to factor in security as well. So these are all the emerging technologies in industrial, which are going to impact industries and how industrial decision making and security happens in the upcoming future. So let's look at industrial machine language use cases to start with. So predictive maintenance, is a very critical part of industrial machine learning. This predictive maintenance has the potential to reduce downtimes. It has the potential to improve production. Yeah, so this is important. Anomaly detection. This eliminates in real time any faults that may be happening on the system. It also enables security by enabling your ability to check on intrusions. Yeah. Process of optimization. This is also very critical. As long as you can use ML and other such techniques to improve your processes, improve the efficiency of your system. This is critical as well. Yeah, machine vision and energy efficiency. These are other critical applications wherein decision making based on imaging and video. Yeah, as well as decision making to improve the energy efficiency. These are also areas where ML can play a very significant role. So let's take an example of smart energy monitoring. Yeah, ML can monitor loads. It can track energy meters via various field bus protocols. It could be Modbus, CAN bus. It could be all the other field bus protocols like Profinet, Profibus, EtherCAT, and so on. So data can come in through any of these field buses. Yeah, they can be monitored. They can be tracked. Yeah. ML algorithms can be used to predict usage, predict vulnerabilities, predict how these processes can improve, and as a result, optimization happens. So this is a key example of how ML can benefit in smart energy applications. And the results speak for themselves. When you use an ML algorithm in these kinds of applications, you can detect faults, you can predict failure. Yeah, 85% of the time. Yeah, sometimes even better, depends on the kind of data that you're able to analyze. Yeah, power saving is significant, 20% power saving at the minimum. Yeah, and this significantly reduces the cost of the system. And ML can also help you secure this in a very significant way. This can be protected, can be encrypted. You can identify using ML critical information that's there in the overall system, and you can protect only that. So you're not encrypting at random all kinds of information. You can use ML to decide which is the critical information that you need to protect, and you can protect it at rest as well as at motion. So these are all the valuable benefits that ML can provide to improve the system. So which are the typical machine language algorithms that are used in industry? One of the most important ones that comes to mind is decision tree. Yeah, this is a very strong algorithm. It's just a tree structure that you would have studied in your computer science class. Yeah, it is designed in such a way that you can pass through the tree, and you can identify and you can make decisions. Some of the use cases that it's used for are classical use cases: fault classification, identifying which fault falls under which category, what to do about it. So all this can be done using a decision tree. Yeah, it's very fast. It's very repeatable, and it gives you a very logical decision making at in real time. Yeah, so this is the advantage. Sometimes, okay, a decision tree can break down a problem into too many smaller steps, so it becomes an overkill. It gives you a lot of smaller steps towards the solution. So it's important to feed data into a decision tree in the right way, so that you get the right decision with the smallest latency. Then you have SVMs. Yeah, these these can be used for vibration detection. Yeah, they work with very small sample data, so they are very efficient. Yeah, the only issue with SVMs is that they are slow in processing larger data sets, so they're tailored to work on small segments of data. Yeah. Then you have k-means. Okay, these are ideal for anomaly detection. They pick up faults very quickly. Yeah, so these are ideal to build out a fault tolerant system. Yeah, they are simple to implement, very fast in processing. Yeah, the only issue with k-means is that they need manual tuning. So you need to be able to take the data sets, sometimes analyze it manually, tune the algorithm so that it gives you the best possible results. So it is tunable, but it needs to be tuned to your specific application. So let's dive a little deeper into decision tree. Yeah. Now these are very good at detecting faults because they work on a two-pronged strategy. A node is there. There are two child nodes that come out of a node. So you either go on path one or you go on path two. So it's very easy to decide. Then you go on that whichever path you select, and then there are again two options. So it's much faster at identifying what are the faults in a system, as you can pass through eliminating other choices and get to the right solution very quickly. Yeah. They offer a very powerful approach for monitoring industrial systems. So if you're looking at solutions that keep track of your machine, keep track of issues with the machine, keep track of your network, issues with the network, keep track of your process, okay, and which are the steps that lead to the right direction, which are the steps that lead to the wrong conclusion. So it's very easy to identify by putting all those parameters into a decision tree. So how does a decision tree work? Okay, each node of a decision tree, yeah, signifies a parameter. So it identifies with a parameter. It could be temperature, it could be vibration, it could be humidity, it could be any number of parameters. But you pick a parameter, you identify a node with the parameter. The branch becomes I mean, we call it a weighted branch. If say, for example, you take temperature, if the temperature is above a certain threshold value, you go the left branch. Okay, if it's below the threshold value, you go the right branch. And then you have another node which gives you another decision parameter. So this way, the leaf nodes, that is the subsequent nodes, provide the final prediction about the whole system. So if the temperature is very high, yeah, you're going to have a wear in your bearings or in the parts of the system. If the temperature is not so high, then you're likely to have not that much wear. So this is how a decision tree can help you quickly pass through and identify what the situation of your machine is. So in summary, I mean, using a decision tree, you can quickly identify faults. You can identify things like overheating. You can get through overheating to decide what the impact is. Okay, you can decide that there is bearing wear. Okay, there is rotor misalignment which causes the overheating, or if none of those conditions exist, then there's no fault in the system. So all of these are very easy to analyze by putting the all the data into a model like a decision tree. So now let's look at SVMs, or support vector machines, for industrial fault detection. Okay. Now SVMs are simpler. They find optimal boundaries between data classes. So they look at a data class. They look at what are the ranges between that data class. Yeah, and they find which are those optimal ranges. So let's look at this a little deeper. Yeah. So initially, an SVM collects data, say, for example, you're looking at vibration levels. Okay, it can generate, it can collect data on vibration levels. Yeah, it can collect how much a motor is loaded, or how much a sequence of motors are loaded. Okay, what are the temperature readings from all this? So sensors feed in the data into the SVM. Yeah. The SVM then calculates the boundary. Yeah, within what boundary is everything safe, beyond what boundary are there violations. So you can set those boundaries, or you can allow it to calculate it. Yeah. And then the classification happens. So depending on the value, if the boundary is exceeded, then the machine is classified as faulty. Yeah, or the machine is classified as something that has more wear and tear and needs to be put through maintenance. Okay, if it's within the boundary ranges, then the machine can be classified as safe, can be operated for a while. Yeah. So SVMs are very good with small data sets, because every time initially they need to calculate boundary. So if you have a lot of data, you're taking too much time to calculate the boundaries or the ranges within which the machine works fine. Yeah. So that's why we say that SVMs are good with small data sets. You can accurately calculate the boundary, accurately predict where the machine is or what the faults are. Yeah. So this is how SVMs work. Finally, let's look at k-means. Okay, these are ideal for, as I mentioned, anomaly detection. Okay, they group data into clusters based on similarity. So anything that's dissimilar leads to prediction as an anomaly. Yeah, so this is also a very, very effective and efficient model that you can use in industrial applications. Yeah. So now let's look at the frameworks. that you can use to implement machine learning in your applications. There's TinyML. This is an ML solution that is ideally suited to microcontrollers. It can run off microcontrollers, so you're looking at very, very low, clock rate microcontrollers. The TinyML is small enough to run on them. Yeah. Then you have TensorFlow Lite. Okay, this is a very, very lightweight deployment again. Yeah, and you have Edge Impulse, which is an end-to-end model building solution. Yeah, and then Onyx, which is for portability. So these are all ML tools or ML offerings that you can integrate into your solutions. Yeah. So let's look at them again. TinyML, okay, runs ML models on microcontrollers, yeah, with very, very low usage of RAM. Okay, so this allows you to build it into your smallest of sensors, which are very, very resource constrained. Yeah, ideally suited for applications like vibration monitoring on small sensors, low cost sensors, where you can run these ML models and get desired results. Now, TensorFlow Lite, okay, this is a Google framework for edge deployment. Okay, so it's Google's attempt to take what it has on the cloud, what it has on the servers, and allow it to be ported into edge devices. Yeah, it's also ideal for utilization with edge devices, things in the 200 to 400 megahertz type of processors. You can use TensorFlow Lite. Yeah. Edge Impulse is an ML pipeline, very easy to integrate into solutions because very, very limited code variations, changes needed. Yeah, it can be used to collect data. Yeah, whether it is sensor data or and so on. It can be used to also train models. It can be put into hardware. Yeah, and can do a whole range of applications. So this is another very, very ideal implementation into edge devices. Lastly, you come to Onyx. This is a neural network platform. Yeah, it allows for modeling interoperability. It converts models between frameworks and is ideal for edge to cloud deployment. So put it on your edge device, help it connect to a cloud interface. All of this works using Onyx. So now let's look at a case study of how we in Pantherun use decision trees in encryption. Now this is a classic case of an edge solution wherein we're looking to build AES based encryption on the edge. Yeah, we use decision trees. We run decision trees on small sets of past data. Yeah, we generate keys using this decision tree implementation on past data. This key is used to AES encrypt data that's flowing between a source and destination. So we run the decision tree on the source, on past data that we've sent between the source and destination, generate a key, encrypt the data. Only encrypted data flows between source and destination. At the destination, we use decision tree again on previous data that has already reached the destination. We generate keys again to decrypt data. So we are able to use decision trees, yeah, to encrypt data using AES. As you might know, AES is a symmetric encryption approach, wherein the same key is needed at the source, the exact same key is needed at the destination. Yeah. So we've eliminated the need for a key exchange, which is standard to most AES implementations. We use decision tree. Decision tree runs on past data, generates a key. As long as you have the same pass data at the destination, decision tree generates the exact same key. So we use decision trees to give very real-time deterministic analysis of past data to generate keys, so that we can encrypt end to end without key exchange. So this is a very clear example of how decision tree can be used on very small edge devices. It can generate very predictable results in real time, yeah, in the form of, as we've done, a key. Yeah, the exact same key is generated every time at the destination, so we can eliminate a key exchange. This shows you how predictable decision tree is, how it's able to run on the smallest of devices, how it's able to run efficiently, because we are able to encrypt and decrypt in real time without any drop in speed up to 10 gigabits per second. So you're looking at nanosecond performance. So what do we do in Pantherun? We like to use ML algorithms. We provide solutions that can encrypt data. Yeah, we are looking at encrypting data on the edge, so we need to be deterministic, and we use ML in all our implementation. So we've got very intelligent edge networking, edge encryption solutions, all based on ML. So this gives you, the confidence that ML can be implemented on the edge to build deterministic, real-time solutions, be it for industrial monitoring, prediction, anomaly detection applications, or for encryption. So what hardware is available that can help you build ML applications on the edge? Yeah, you of course have NVIDIA, you have the Jetson. Yeah, this is very well documented as a acceleration platform. Yeah, of course, does mostly AI, can be adapted to do ML as well. Is a good platform as long as it meets your budget. The other alternative is to use ARM Cortex microcontrollers with neural processing units. You have hardware available that can do this as well, and this sometimes builds in things like TinyML, TensorFlow Lite, and so on as well. So there are platforms available that do this. Yeah, we in Pantherun have also a platform that we call Pepper. Yeah. This is FPGA based, so we have an FPGA built into the board. We have also Ethernet ports. We've got 4G interfaces. We've got 5G interfaces. We've got Wi-Fi. We've got Bluetooth. We've got GPS, all on one single platform, along with an FPGA. The FPGA controls all of the networking and routing. Yeah. On the ARM side, you've got spare processing power to implement your applications. We've got an AI ML accelerator as well built into the FPGA, so you can run ML applications on it. You've got IOs, so you can read IOs. You can do analysis on it. You can pass decisions over field bus or Ethernet, or you can send data to the cloud. So this is a platform called Pepper, which is FPGA based, which is also completely open source. So you can take the designs, you can customize it, you can build your own product with it. So just some highlights of Pepper, just to reinforce it. Has FPGA fabric, so it has logic blocks, so you can program the FPGA as well. You have RAM, DSPs, and so on built into the FPGA. You have security, so we give you AES encryption, we give you PQC proof, key exchange free AES. We give you various kinds of interfaces to build your product on: GPIO, ADC, UART, CAN, SPI, I2C. Yeah. Then we have connectivity like layer 2, layer 3 network stacks, and so on. So it's an all-inclusive platform, all open source for you to build your next generation edge device with ML-based decision making. In addition, what Pantherun also offers you as along with the product is encrypted Ethernet layer 2 and layer 3, no jitter. Okay, the ML acceleration algorithms, yeah, and you have timing in terms of hardware implementations. You have advanced security. You don't need SSL or TLS. You can build AES without key exchange. And this can be used for many applications, just as you would use a lot of embedded platforms that you get in the market. You could use it for monitoring, you could use it for analysis, you could use it for generating alerts, you could even use it because of the IOs for certain level of controls. And why would you choose Pepper? If you need an embedded product which just has software to be developed, you have a whole range of products that are available to you, including with AI and ML acceleration. But if you need a product which requires higher performance, greater security, okay, because Pepper comes with an FPGA, so you can actually program some of the decision making on the FPGA itself using Verilog. So it gives you greater flexibility, very, very clear real-time performance, very, very high performance. Yeah. And also gives you extensive security platform to build into your solutions, particularly now that there are so many laws being passed, like the resilience law that's coming into force in Europe. There's also the quantum computing laws that are coming into force in the US. So you need security in your next generation uh, edge device, particularly if you're going to use ML, you're going to use AI, you're going to make decision making on its own on the device. You will need to have data security so that the ML algorithms or the AI algorithms run on very, very valid data, something that's not been compromised. So, it is not hard to implement these. You need to make an assessment of the use case. You need to make the assessment of requirements. You can deploy Pepper or other hardware, as I mentioned to you. If you're just looking at embedded software, you have lots of options available. If you're looking at deterministic real-time performance, you have an FPGA-based platform like Pepper available. Yeah, you need to train the model that runs on the platform, and you need to optimize and fine tune it to the specific environment. It is not hard to implement ML algorithms. It takes a little bit of practice, a little bit of uh, drive to be able to do it, but it is not hard to build. And we're always there. Pantherun is there. Pantherun's Pepper is available. You can go to pepper.pantherun.com and you can register to get your own Pepper to start working with. But other than that, we're also happy to help with any consultation if you need some help on deciding what algorithms to use, what platforms to use, what works for you. We're happy to suggest things to you. Yeah, if there's a need, we can also help you make a proof of concept. We can help you with your deployment strategies, and then we can also help you with support. All this is available because we're keen to look at ML as the next big improvement on the industrial side. So that was my presentation. Thank you very much for listening to me and giving me this opportunity to share what I've learned in this field. Over to you, Rich.
Thank you very much, Sri. So what you learned is what I learned. So that was really good. I appreciate you taking the time to walk us through those steps.
Thank you.
So we have a bunch of questions, and let's get to them. Let's see. What's the point of ML in K-means? I don't know what that means. If it needs manual tuning.
Basically, I mean, a lot of algorithms in the market today require some level of manual tuning. Yeah, I mean, you look at data, you look at which are those pieces of data that work for you, that you want to use to train the model, which are those which maybe, I mean, not really fitting into the right segment. They may be corner cases that can be ignored and so on. So all models require some level of manual tuning. Yeah, some a little more than others, particularly the ones that look at smaller amounts of data or look at, I mean, coming to decisions faster require some more of manual tuning, which is where k-means falls in. So that's why you need some more manual tuning in the case of k-means.
Okay. Here's a longer one. I'm just going to pull part of this, which I think is really appropriate. Why do very few edge devices use encryption today? That's a good question. What the heck?
Yeah, it is a very good question. Thank you for asking that. Yeah. Edge devices today typically need to be low cost, need to be very application specific. Yeah, so I mean, you're looking at I mean, very low end processors, not a lot of memory, not a lot of storage space. Yeah, so can you I mean, the general feeling has been we cannot afford to put encryption there because encryption takes a lot of resources. Yeah. That's changed. Pantherun and a few other people are working on AES encryption implementations on the edge. Yeah. Pantherun is probably a little ahead, at least we believe so, based on what customers tell us. Yeah, we've eliminated the need for a key exchange. Key exchanges are a big vulnerability of AES. Key exchanges also take significant resources because they need to go back and forth before encryption starts. Yeah, so we've eliminated that, makes our encryption much more suitable to edge applications. So which is why we're seeing much more adoption of AES now with our implementations on edge devices. And we hope to keep seeing that happening. Laws are coming in as we discussed as well. So it is now necessary that edge devices also get the protection that they deserve.
Excellent. Okay. This next one, I'm going to paraphrase this one a little bit. Is it better to use hardware acceleration or use a software-only approach for machine learning?
It depends on the kind of budget you have and the need that you have. Okay, hardware definitely gives you much better performance. So do you need that kind of performance? Yeah. If so, you may have to spend a little more on a hardware accelerator. Yeah.
What would dictate how much performance that you need?
If you're looking at decision making in micro or nanoseconds, you're looking at hardware acceleration. Yeah, so when you're getting data that you need to analyze, data is coming at 1 gigabit per second. You need to make decisions based on that. Okay, then you're looking definitely at hardware acceleration. If you're looking at something in the 10 to 100 megabits per second of data coming in that you need to analyze, you can do this with software. So that would be my way of judging it. And the price points are not significant today, but because, I mean, silicon with ML and AI acceleration, not that expensive. The problem comes with hardware is you need to change hardware. You need to design hardware. You need to put a chip in. You have time and expense and certification towards building out a product that way, which is why people tend to go towards software.
Okay. With SVM, does machine learning set the sensitivity of the boundary?
It can. It can set the sensitivity of the boundary with SVM. Yeah, but that is also something that you can do. Yeah, so that could be a uniqueness that you see with the implementation that you do. Standard SVM does not set sensitivity, but you can customize it to set sensitivity of the boundary.
Okay. From one of our non-believers, when you say no latency, what do you really mean?
Again, very good question. No latency is a marketing term. Yeah, it just means very minimal latency. Let me give you an example. Say you have an Ethernet switch. Yeah, today even the market leaders, when you come to Ethernet switch, when you bring in data into an Ethernet switch at 1 gigabit per second, after analyzing which IP address to switch to and so on, and switching, okay, the switch performs at about, sends out the data at about 930 Mbps. So you're looking at a 7% drop in throughput. This is not loss of data, it's just drop in throughput. Yeah, this is considered wire speed. This is considered no latency because it's just the hardware latency. Yeah, so when we talk about no latency, we look at these kind of industry standards. What Pantherun does today is, since we are FPGA based, FPGAs have great transceivers, so we are actually able to switch data, including encryption, at better speeds than other SoCs switch data. So where they do 930 Mbps without encryption, with encryption we are able to consistently do about 950 Mbps, including switching and encryption. So that's why we call it no latency.
Very good. If this was a written piece instead of a verbal one, I'd put in a link to a podcast I did not too long ago that was titled something like, "What does real time really mean?" But anyway, I digress.
Okay. Very relevant, Rich. Thank you.
How scalable is Pepper? And then can I add additional nodes in a divide and conquer strategy?
I would say yes. I'm assuming you're looking at other nodes being maybe something additional to the one node that the model works on. If so, it is quite scalable. You know, I mean, the ML algorithms that we currently implement use very little resources on Pepper. So Pepper, we do a certain averaging out of FPGAs. We are also giving an FPGA which is quite high performance. You can put in a lower FPGA if your cost demands that. So depending on what kind of load you want to put on the device, on the FPGA, on the processor, you would size your processor accordingly.
Very good. This is the last one we got here, unless anybody else has any. How many machine learning algorithms have you ported to Pepper?
We've currently done we've done TinyML. We've of course done Dictionary because we use Dictionary as well. Yeah, we have TensorFlow Lite. So these are the ones that we put on. Yeah, not hard to put the rest in as well. Yeah, we just didn't use it in any application, which is why we didn't put it in. But Pepper is an open source platform. It's a community. Yeah, happy to encourage people who work with Pepper to also contribute to it.
Okay. Sure. Here's somebody who's convinced. Is there a buy now button on pepper.pantherun.com?
There is a register now button, so please feel free to register. Yeah, and we will get you your Pepper as soon as we can.
Awesome. I think we've ran through them, Shri. Good job. Very good job. As hard as I tried to stump you, I was not able to.
Thank you so much, Rich.
Okay. I'd like to thank Shri for a great presentation and also Pantherun for sponsoring this event. And of course, we'd never be able to do any of these things without you, the engineer. A final reminder that all Open Systems Media webinars are copyrighted and may not be recorded without further permission. Don't forget to register for our upcoming webinars on artificial intelligence. And in that same box, you can find if you want to see the ones that we've already done. So thank you all for attending, and I hope everybody has a great day. You too, Shri. Thank you much.
Thank you so much, Rich. Thank you, everybody. Wonderful talking to you all.